Okay, good afternoon to all of you. Now today we will discuss to study the interference of light by Newton's ring experiment. So what is the aim of the experiment? To determine the wavelength of sodium light by using Newton's ring. So you need to calculate the wavelength of the light by using this Newton's ring experiment. So before going to start the experiment, I will mention few information how to perform this experiment and how to write the copy, right? Suppose you have been given a website and you must click on the link of the website, then you will get the apparatus and software how to perform the experiment that I will discuss. Then you will go to that virtual lab, that is software based lab, virtual lab, and you need to perform the experiment. You have to collect the data, then you need calculation and plot the graph and calculate the result. After doing all these things, then you have to maintain all these things in your copy, right? And this copy will be A4 or sheet, right? It may be ruled or unruled A4 sheet. In that sheet, you have to write these things. You have to write the aim, apparatus, and theory of the experiment. Then you have to put the data in a tabular form. Then you have to show the calculation, graph, and equation. That what we consider here if we perform this experiment physically, that you have to write, right? Then you need to submit the practical copy, right? It should be in A4 size sheet. Then you need to submit this practical copy, maybe online mode, right? So you have to scan and then you submit as a PDF file. We will discuss 4 experiments at present, right? We will discuss 4 experiments in 4 consecutive weeks. And for each experiment, you can allow maximum 4 to 6 pages, not more than that. You will be allowed 4 to 6 pages to complete one experiment, right? And during experiment, you also collect the screenshot. If you start your experiment by using your mobile or by using your computer or laptop, then you must take the screenshot of the data. When you are taking the data, during that time, you should also take the screenshot, that it is the evidence that you have performed the experiment in that particular date, right? So you have to put this picture in your copy where it is mentioned, right? And after completing this 4 experiment, you have to perform the experiment in virtual lab, and you have to write up all these things. Then you should be ready to submit the copy, and you have been given a particular date and time. Suppose at the end of this semester, one date will be fixed up and time will be maybe 30-minute slot. Within that 30-minute time slot, you must submit it by email to me, right? That is your laboratory notebook. And at the end of this experiment, when we complete this experiment, then we will conduct one examination, online examination, that based on this experiment, that may be multiple choice or maybe some other types of question will be set, and you have to answer in online mode. Point is clear? That examination will carry 40 marks, and these 4 experiment performance of your experiment, it will carry 60 marks. 4 into 15, that is 60 marks. Can you understand?
Sir, can you please specify tentative date for the exam?
Tentative date of exam, that I cannot say at present, but when all the experiment will complete, then we will decide the date of exam.
Okay, sir.
Sir, can you repeat this?
सर 30 मिनट क्लॉक टेक पर बोलबेन.
After completing all the experiment, then you have to write up all this experiment data, everything what I have mentioned. Then you need to submit this laboratory notebook, that is this copy, containing 4 experiments, right? In a particular date that we will decide later on. In that particular date and time will be also decided. Maybe 30-minute slot will be given to send the laboratory notebook by email.
ওকে স্যার স্যার দেয়া স্যার চারটি এক্সপেরিমেন্ট আছে শুধু নাকি ওই সেকশনে আরো আছে?
No, there are more experiment is there, but in online mode we can offer only these 4 experiment. And if you come in the campus, then if time will permit, then you have to perform remaining other experiment. Okay. Otherwise, if it is in fully online, then we will discuss only these 4 experiment.
স্যার বলছিলাম যে A4 সাইজ শিটে লিখতে বলছেন, তো কপি কোনো কিছু বানাতে হবে না তাই তো? ওটাকে পিডিএফ বানালেই হবে তাই তো?
Yes, you have to write all these things in A4 size sheet, but you are restricted 6 pages for each experiment. 4 experiment, 6 into 4, that is 24 pages. Maximum 25 pages. That is your top sheet. Your name, roll number, all such information will be present in the top sheet. So there may be within 25 page you have to complete, and the size of the file, it should not exceed 2 MB. The size of the file should not exceed 2 MB. Maximum allowable range is 2 MB. It will be of the order of KB or maybe 1 MB, but I will allow you up to maximum 2 MB containing this 25 pages. You have to remember these things.
Sir, we have to put screenshots of the data in the PDF.
Yes, you have to take the screenshot when you will perform this experiment. You will perform this experiment. During that time, you fix up a particular reading and take the screenshot of that. That is the evidence that you have performed this experiment from your own. You have not copied from your friend. Is it okay?
Okay, sir.
Now we'll start the experiment. Right. So in Newton's ring, what are the apparatus? What are the aim of this experiment? The aim of this experiment to determine the wavelength of sodium light. Right. We need to calculate the wavelength of the light used in this experiment. So what are the apparatus? Basically, we need a traveling microscope, sodium vapor lamp, a thin plano-convex lens of large focal length, a convex lens of short focus, and optically plane glass plate. These are the apparatus, and you see the experimental arrangement is like this. This is the glass plate, and this is the plano-convex lens. This is plane surface, this is convex. Plano-convex lens, and this is convex lens, and this is the sodium vapor lamp which is present in front of the focus of this lens. Then this light beam is parallel and it will fall on a glass plate G. Right? This glass plate, inclination of this glass plate with this incident beam is 45 degree. This angle is 45 degree. This angle is 45 degree. So what will happen? It will make towards this direction and it will fall on this plano-convex lens in normal. It will fall normally. And then after this curved surface, it will goes reflected and transmission. So reflected like this. You see, this is the incident beam. Then there is one reflection from the plane surface of the plano-convex lens. Then another part will reflected at the curved surface. Now it will be reflected back by the curved surface. One part, another part will transmitted. This is the transmitted part. And then this transmitted part again reflected back by this glass plate, this surface of the glass plate. And then it will goes like this. And the third one, that it also again transmitted through this glass plate, and then it will reflect it back again, and it will show you this type of beam. Or another way we can say, if this surface is open, then this beam will transmit through this region. It will transmit through this region, right? So we see that there are two reflected beam. One is backed by this curved surface of the lens. Another is backed by this glass plate from this surface, top surface of the glass plate. So if we unite these two beam, then we can observe the interference pattern. And this interference pattern will be circular in shape. This will be circular in shape, right? So what we how it will looks like, that we can show you. It will looks like this type of ring pattern we can observe, right? This is your bright, this is dark, this is bright, this is dark, and like this way we can observe the ring pattern. So this is the experimental arrangement. And under oblique incidence, we have explained how we will get this two beam. Because you know there are two beam is needed to produce the interference pattern. One is reflected back by the curved surface, another is reflected back by the glass plate, right? Then we can unite them to observe the interference pattern. Now, here the working formula. One thing I will mention, you see the beam, it is marked as 2, it is reflected back by the curved surface of the lens, right? Now this region is air. We consider this region is air. In between glass plate and curved surface of the lens, this is air. So that's mean this beam 2 reflected by this curved surface, basically after that this is a rarer medium. But the beam 3, it is reflected back by the glass plate, this glass plate, and this is the denser medium, because ray is coming from rarer medium air to glass plate and after reflection. So here the path difference, it will introduce a extra phase difference. That extra phase difference is pi here, right? We will discuss this thing why it is pi in theory class, but I will inform you that there is a abrupt phase change when it is reflected back by denser medium. If a light beam reflected back by denser medium, then it undergoes a phase shift of pi. So this beam number 3, it undergoes a phase shift of pi. So here the condition of maxima and minima that we can write, and depending on that we can determine the wavelength, right? So here you consider the working formula for calculating the wavelength, that is d square n plus m square minus dn square divided by 4 mr. Here this is the diameter of n plus mth ring. dn plus m is the diameter of n plus mth ring, and dn is the diameter of nth ring, right? And m is the number of ring in between n and n plus mth. There are m number of rings is there. So this is the ring pattern. So suppose if we consider this is your second ring, if we take this reading, and after that if we count, this is 1 2 3 4, if we take this reading, then here m equal to 4, because this is 4 plus 2 6th position, that is m plus n equal to 6, and this is n equal to 2. So there are 6th ring we are taking, this 2 and 6. This diameter we have to calculate, and then we will
Sir, can you repeat
determine the wavelength.
diameter?
Yes.
Can you repeat how to calculate the diameters?
Yes, that I will mention. You wait. Now, the apparatus is look like this, right? This is the arrangement, and we are measure. If we see through this eyepiece, then we can observe this type of ring pattern, and there is a crosswire, right? And at the same time, you see there is a scale arrangement, so we can take the data from here, from this scale, right? Now, if we fix up this second ring, this position, and in this position here, then if we take these two reading, the difference will gives you the diameter of the nth ring, that is n equal to 2, second ring. So we can calculate the diameter of second ring by taking this reading, this side and this side. Yeah, that is one. We have to take reading of left side and right side for a particular ring, and we say it is n equal to 2, second ring. Then again we will take the difference between these two reading, that is the diameter of n equal to second 2, second ring. Next we count, there are 6 number of rings. Then we come to here, that is the 6th position, that is n plus m equal to 6, where m equal to 4. Then we will take the left side reading and we will go to the right side. Then we will take the reading of the 6th ring, that is n plus m equal to 6, right? And we will take the difference of these two, that is the diameter of n d n plus m3, right? Then we have to take the difference according to this square and difference. Then we divide it by 4 into m, m value that we know, and capital R. R is the radius of curvature of the plano, that is radius of curvature of the convex surface of the plano convex lens. Convex surface of the plano convex lens, that is the radius of curvature. So this is supplied. So if we put it, then we can calculate the wavelength of the unknown light. Point is clear?
Yes, sir. এই এক্সপেরিমেন্টটা পরে থিওরি ক্লাসে বোঝাবেন?
Theory, that theory part is also there, that we will discuss maybe after 1 or 2 class. We will reach in Newton's ring, then we will explain this formula. Okay.
Sir, the diameter, the calculation of diameter portion is not clear to me.
Okay, I am coming to that. Now after taking this, you have to put the reading here, that is left hand side reading, right hand side reading, ring number, that is n. N equal to, suppose you start from 2. In second ring you take left hand side reading, that is main scale reading, vernier scale reading, then total reading. Right hand side reading, main scale, vernier scale, total reading. Next you calculate D, that is the difference, right? That is the diameter of the second ring. Then you take third, then fourth, fifth, sixth, and like this way you can continue. Okay, so this is the main scale and this is the vernier scale. This is the main scale, lower one is the main scale and this one is the vernier scale, right? I think all of you know how to calculate the vernier constant from this. Now there are 50 division, it will match with 49 division, right? Then you can calculate the vernier constant that you have already learned in your +2 level, right? So first you have to take this reading at 0, that is the main scale reading. Then you see which vernier division will coincide exactly with this main scale. You count that number. Suppose this number, that is 42, right? This is 42. In between there are 10 division. So if we consider this second one, then this is 40, 41, 42. So 42 multiplied by vernier constant, and that will gives you multiply it vernier constant and add to the main scale. That is your total reading according to this vernier scale reading. vernier total number of count in vernier scale multiplied by vernier constant, that is vernier scale reading, then total reading, and take this difference, that is the diameter of the particular ring, that is 2, 3, 4, 5, 6, like this way. Now here you take, that is n, ring number 2, 3, 4, 5, like this, then you calculate dn, then dn square, and dn plus m, dn square. Suppose you take 3 or 4, right? M equal to 3 or 4, right? Then here you have to write, if it is 3, then you have started from 2, 2 plus 3, 5. So what is the fifth ring? This ring. This is 2, 3, 4, 5. So this diameter minus this diameter, you put it here. And like this way, you will continue. And then you take the mean of that. You take the mean of this reading. Then you can calculate lambda. dn plus m, that is mean, dn square. This mean value divided by 4 mr, that is the result, that wavelength, unknown light. And this is the precautions. Next we go to the experiment, then you can understand. So you see there is a link is given here. So you click on the link and you directly you will go to the experiment. Now I am clicking here. Then you see it goes to the virtual lab, right? It goes to the virtual lab. Now, so first, to perform this experiment, you select the medium. Medium means I have already mentioned that you have to consider the air in between glass plate and curved surface of the lens. So it is already mentioned. What will happen? Okay, it is air. Then light source. Here different. It is mentioned sodium. We will take, and then we light on. We click it here. Now you see, this is the ring pattern. You can observe the ring pattern, right? And radius of lens, that is 50 centimeter. That is curved surface. That is curved surface of the plano-convex lens. That is capital R. That is 50 centimeter. Now you see, this is the pattern, circular ring pattern, right? You can count. This is ring number 1, 2, 3, 4, like this, right? So this is the microscope position, right? So if you change it, then what will happen? A ring pattern are moving left and right side. At the same time, you see that scale reading is also changing, right? Scale reading is also changing, right? So we fix up at the middle position, right? And this is the focus of the microscope. That is, it is present at 7.5. So if you change it, then you see that it is defocusing, right? It is defocusing. So we fix it at 7.5, right? Now this is the main scale and this is the vernier scale. This main scale is here and this is the vernier scale, this vernier scale, right? So you need to fix up the position. Suppose if we go to the left side, you see we are fixing at the ring position, second ring, right? We have fixed at second ring position. Then you can see this reading. This this main scale is 3, so it will be 2.5, and then it is 2.4. This is 2.3. So this is 2.35. 2.35. Then 2.35 and 2.4. This 0. So now you have to count which reading in the vernier scale will match exactly to this main scale. Right, so our main scale reading is 2.35, and then you see vernier reading. Almost you can see this is 30 division. This 30 division is matching almost exactly, you see.
Sir, I think 4 is matching, sir. 4 in the mean scale is matching with the vernier scale.
4. Okay, so this reading is, this is 30. So this is 31, 32, 33. It is 33. So your vernier scale reading is 33. So now what is the vernier constant? That you need to calculate. This one division is 0.5 millimeter. That maybe 3 to 4. This is in a millimeter scale. So how much division? This is 0.1 millimeter. This is 0.5 millimeter. Right? So it is 0.5 millimeter, and there are 50 division, and here it will match with 49 division. Right? So that you need to calculate. That is 0.5 divided by 50. Then what will happen? That is 0.001, right? 0.001. So if it is 33, then 0.033, and main scale reading is 2.35. So your total reading will be 2.383. 2.383. That is millimeter, right? This is the reading. Right, like this way you have to take this reading, and then you take next, this is third one. You see it is matching third one, and third, fourth, fifth, like this way you will complete left side, and after completing left side you go to the right side by changing this microscope position, and you will take at the second ring position, right, in the right side, then third ring position, then fourth ring, and like this way you will continue and take all the readings, right, as much as possible. Maybe at least 7 to 8 readings you take in left side and right side, starting from 2. Right, then you have to take the square of that diameter. You calculate the diameter and square of the diameter. Then you fix up the value of m, maybe 3, maybe 4. It depends on you. Right, then you will calculate the differences. That is d square n plus m minus dn square, and take the average value. Right, and then you calculate the lambda. Is it okay?
স্যার
So can you repeat
diameter-টা
this?
বুঝলাম না।
Which one?
So M and N.
Repeat once again, I cannot understand.
Sir, how to calculate M? That part. How to get M?
Yes, sir. Sir, the actual confusion is, sir, which two differences will take? D3, D4, how differences will be taken, sir? Which two one?
Hello, you see, you have taken this reading. You notice my cursor. You have taken this reading, right, in the left side, and you take this right side reading from this scale arrangement, and this difference will gives you the diameter of the second ring. Similarly, you take this third position of this ring in left side and third position in right side, and take the difference. That will gives you the diameter of the third ring. Like this way you have to calculate. You see here.
So তাহলে তো
left-hand
আমরা
side
চারখানা
reading. This ring order number 2, 3, 4, 5, 6. Then what will happen? Left hand side reading, right hand side reading. That is the diameter of the second ring by taking these two difference. And this third ring, you take this difference, that is the diameter of third ring, fourth ring, fifth ring. Like this way you will complete this table. Then this value you put it here. These differences, that is the diameter, and the ring number, that is 2, 3, 4, 5, 6, like this. And this is the diameter of second ring, third ring, fourth ring, fifth ring, sixth ring. Then you take m equal to 3. Then what will happen? This difference will be n equal to 2 and m equal to 3. That is fifth ring. So d fifth, that is d5. Which one? 2, 3, 4, 5. This one. D5, this reading minus this reading. Or sorry, here. This reading minus this reading. That you will put here because it is dn square. Right? And then you take the mean of this average value. Can you understand?
Sir, for D5
Now-
it's okay. Sir, suppose we go for the second one, then D6, then for the third one D7. Sir, D7, like we have to calculate for, means how are we picking the value of M?
So you take m equal to constant 3. Then first you have taken the differences between d5 minus d2 square. Then second one you have to take the difference, that is d6 square minus d3 square. Right? That third ring. Then you have to take the difference d7 square minus d4 square. Can you understand?
Yes, sir.
Right? M equal to, you take 3. It is fixed. And n value will change. For this you will write n equal to 2. Here you take n equal to 3, n equal to 4, and like this way it will continue. Then you
So
take
what-
the average. Yes.
What is aim here?
M is a constant value, that is n plus m is the diameter of a particular ring. This is clear. All of you click on the link. Then you perform this experiment. I am sharing this. I am sharing in your mind.
Hello, sir.
I am sharing. You see. Where I have uploaded interference of light, in that folder I am uploading. Now I have already uploaded. So you open it and click on the link. Then you go to the virtual lab and perform the experiment. Then you can understand.
Yes, sir, the link is opening.
You have got?
Open the link, sir. Or something
Yes,
like.
you open the link and start the experiment. Then you can understand.
रिजेक्ट कर रहे हैं। Sir, we have to submit the results right now.
Hello?
Sir, we have to submit the results right now or later.
No, not right now. You have to perform, you will complete all these things, write up, aim, how we will write the copy, laboratory notebook. That is name of the experiment. Then you have to write the apparatus, aim of the experiment, apparatus, theory. Then you have to do the table, and you have to put the data in the table, then calculation corresponding. Then you have to plot the graph, if any, then you have to calculate the result, then equation or discussion, then it will complete. And along with this, you have to take the snapshot, right, of when you will perform the experiment. That you also put in the copy.
Okay, sir.
Sir, while taking PDF, we will also attach the screenshots.
Yes, one or two screenshot. You will, when you perform this experiment, you will take either one screenshot or two. Maximum two screenshot you can take.
Okay, sir.
That is the evidence that you have performed the experiment.
So can you please repeat the table 2? Now we can understand.
Table 2, yes.
Sir, one
That
question,
is
sir. Can we take the value of m to be 1?
M.
Yes, m.
You can take, but I suggest you take more than that. Maybe 2 or maybe 3 you can take.
Okay, sir.
Now you see, you have calculated the diameter. That is, from seconding you have considered, that is D2, D3, D4, D5. You put it here, the diameter, right? And here you put the ring number. What is the N value, right? That is 2, 3, 4, 5 like this, right? And the mean diameter. Sorry, mean or only diameter, this. Then you calculate dn square. You take the square of this column. Then here you calculate taking m equal to 2. For example, m equal to 2, or for example, m equal to 3. Then if you take m equal to 3, then d here n, this is 2. Minimum value is 2, n equal to. So this is 2, and then 2 plus 3, 5. So d5, that's mean this reading, d5 square minus this, you put it here, right? Then d6, this one, d6 minus d3, you put it here, and like this way you complete and take the average.
So কটা রিডিং নিতে হবে এভাবে?
You continue from 2 to 8 or 10. 2 to 8 or 10. That is diameter. You need to calculate the diameter of seconding, third, fourth, fifth, sixth, 7, 8. and if it will permissible, or if you can take the data, then you can go up to 10. But you try to take up to 8.
Sir, one thing, sir, while noting the reading, sir, the vernier scale that line is coinciding with many main scale lines. So, sir, which one to take?
So that it is not coincide with many, but in one you have to take the most coincident. That which one is coincident almost exactly. That you need to find out.
Sir, but it seems from the image, sir, like more than one are actually
Yes,
coincide.
sir. Sir, we
If,
even zoom
if it is, listen, if it is seems that more than one, then you take the middle one. Right? Suppose for 3 consecutive, you are observing that these 3 consecutive, both are all 3 are coincident. So you take middle one. Right?
Okay, sir.
So now I can leave from this meeting. So you can perform the experiment. You can do now this experiment, or if you not complete, then you can do it later on also. That is also permissible. This link will be active. Okay, this link will be active, but you have to complete within this week. Next week I will explain next experiment.
Sir, can you repeat how to find
Sir, one
total?
thing, sir, do you have to write the procedure in the copy?
Yes,
Okay, sir.
you need
Sir,
to complete this experiment within this week. Next week I will discuss next experiment, and link will be active for this week. So you can do it today or tomorrow or day after tomorrow or next day, and like this way you have to complete it.
Sir,
sir, can you repeat how to find total?
Why total?
Main scale, one scale, and then the total part in the table one.
Total means main scale reading, then you add vernier scale reading. How you will calculate vernier scale reading? That is, you have to find out the number vernier scale which number will coincide to your main scale exactly. That number you first find out. Then you multiply it with vernier constant. Then you add with the main scale reading. That is your total reading.
Okay, sir.
So now I will leave this meeting.
sir, then what those are there in this PDF only that we have to write